This is a summary video for the equations used with curved mirrors. Alright, so on the screen I've got a little concave mirror, so it's curving around kind of like a cave. And I've got an object to the left. The distance between the object and the line of action, that's the front surface of the mirror, that's going to be what we're calling S. The distance to the image is called S prime. Now, S and S prime are not universal. Some textbooks will use P and Q, some places will use the letters U and V, but for us it's going to be S and S prime. Now let's talk about where the light belongs, where the light doesn't belong. On a mirror, the light will come in this case from the left, off the object. So everything that appears in the yellow area, that's where the light belongs, and all of our variables are going to be positive when they're in the yellow. But in the dark side, well, that's the virtual side, hence the term virtual reality. In the virtual side, there's not going to be any light. Light doesn't belong there, so the reflected light all stays on the left. So after the image, or any of our variables, I should say, if they're on the dark side, they're going to be negative in the math equations. First equation is the lens equation, which we're using for mirrors. So I think of it as the mirror equation. It's 1 over S plus 1 over S prime equals 1 over F. In other words, the inverse of the focus is the sum of the inverses of the distances. Now, when you're putting in the variables, make sure you pay attention to the signs, positive and negative. That's very, very important. Magnification is used for a lot of things besides just how big or how small an object appears. Magnification, nice thing is it has one universal aspect to it, and that's that the image information is always on top in the numerator, and the object information is always on the bottom, that is in the denominator. So it's the image height divided by the object height, and that's equal to the negative of the image distance divided by the object distance from the line of action. Now let's look a little bit more at this magnification. If you put in the right numbers, paying attention to the signs, if you put in those right numbers, negative magnification and positive magnification, they tell you more than just how big it is. If it's negative, that means the image is upside down or inverted. If it's positive, the image is upright, so it's the same orientation as the original object. And our distances also have some signs associated with them. If the image is positive, that means it's real. It's where the reflected light belongs. If the image is a negative S prime, it's where the reflected light doesn't belong. It'll be here on the dark side, or in this case, the back side of the mirror. So those are our signs we got to contend with when doing all the math work associated with curved mirrors. Sorry. Now let's talk about a convex mirror. So a convex mirror, cool thing is the formulas are going to be identical. Here's what's coming in. Got the light coming in. Again, where the light belongs is positive. In this case, it's going to be S. And I can have negative S prime, R, C, and F. So I can have a negative focus and a negative center of the mirror, or the negative radius, because the mirror is curved backwards. And so to make this, I'd have to take a protractor and stick it where C is, in the dark side where the light doesn't belong, the reflected light doesn't belong. And the equations are the same, the rules are the same. That doesn't change, except you got to realize that when you have a convex mirror, sometimes you can refer that as a negative mirror because the focus will be negative. And then the concave is a converging mirror, which is also a positive mirror because the focus is positive.